Okay, let's dive into this. If you've ever sat through a physics class, you probably remember dimensional analysis. It was, that dry math chore your teacher made you do just to double-check your homework. But what if I told you that it's actually the ultimate cheat code for understanding the universe? Welcome to this explainer. Today we're going to unlock one of the absolute most powerful, secret tools in all of science. Because dimensional analysis, it's not just about catching typos on a test. It's a literal engine of discovery. It reveals the hidden structure of physical laws, even when the underlying equations are completely unknown to us. To show you exactly what I mean by a cheat code, let me tell you a genuinely thrilling story about the British physicist G.I. Taylor. So picture this. It's 1950, and the energy yield of the first American atomic bomb test, the Trinity test, is a highly classified military secret. Locked down tight. But the military had declassified and published a few seemingly simple photographic sequences showing the expanding fireball over time. Taylor gets his hands on these photos, and by purely analyzing the physical dimensions involved, the energy released, the time elapsed, and the ambient air density, he built a mathematical relationship. No blueprints, zero classified data. He just deduced the top-secret yield of the bomb to be roughly 22 kilotons of TNT. He did it using pure dimensional reasoning, and man, it famously caused a lot of consternation among US officials. So how does this high-stakes atomic math actually work? Well, it's honestly quite elegant. Let's bring this incredibly powerful concept back down to earth with an everyday logical concept that you already know.
Section 1. Apples and oranges. Dimensions versus units.
Right off the bat, there's an absolutely critical distinction between a dimension and a unit. A dimension is the intrinsic physical nature of something. It's what kind of thing it actually is, like length or time. A unit, on the other hand, that's just an arbitrary human convention we use to assign a number to that dimension. Think meters, feet, light years. Honestly, it's a bit of human arrogance to think the cosmos actually cares about the length of some old king's foot. The fundamental laws of physics simply cannot depend on whatever random units we humans happen to invent. A rock falls the exact same way whether you measure its speed in miles per hour or meters per second. Because here's the crazy part. Absolutely everything in the physical world is built from just 7 foundational blocks. 7! From the massive gravitational waves rippling across galaxies, all the way down to the tiny forces folding proteins inside your cells, every single physical quantity is expressible in terms of length, mass, time, electric current, temperature, amount of substance, and luminous intensity. That's the whole shebang. They are the complete alphabet of the physical universe.
And that brings us to a literally unbreakable universal law, the principle of dimensional homogeneity. Simply put, in any meaningful physical equation, every single term must share the exact same dimensions. It's basically the ultimate, scientifically rigorous version of the rule: you can't add apples and oranges. You can never, ever add a mass to a velocity. You can't subtract an energy from a force. It's just physically impossible. If someone hands you this massive complex calculation and the final answer is supposed to be a speed in meters per second, but the dimensional math works out to kilograms, boom, you instantly know the math is completely wrong without having to check a single number. So, with that rule in mind, let's step it up a notch. We're moving from basic homework checking rules to what is essentially the ultimate scientific secret decoder ring.
Section 2. Pure numbers. The Buckingham Pi Theorem. This brings us to a concept that is, quite frankly, pure magic: the Buckingham Pi Theorem. When scientists are faced with an impossibly complex system, they use this exact checklist. First, they list all the relevant variables. Next, they express each one in terms of those base dimensions. Then, they determine the rank of the dimensional matrix. And finally, they reduce everything into independent, dimensionless pi groups. I know matrix math sounds intimidating, but think of it as an easy, magical checklist. Instead of running millions of expensive, time-consuming experiments, this theorem completely collapses complex problems in just a fraction of the time.
One of the most famous results of this process is the Reynolds number, or RE for short. This number is like a magical lens for fluid dynamics. It's a pure ratio of inertial forces to viscous forces in a fluid flow. And because the dimensions perfectly cancel each other out, it leaves behind a pure number, no units. And it universally predicts whether a flow is going to be smooth, which physicists call laminar, or totally chaotic and turbulent. And get this exact same number applies to the massive airflow over a jet airplane's wings, the heavy water flowing in a huge river, and even the microscopic flow of blood pushing through the tiny vessels in our bodies.
Now, you might be wondering, why does this matter to me? Well, let's take a look at biological scaling.
If you double the size of an animal, its body weight, which depends on volume, increases by a cube factor. But its bone strength, which depends on cross-sectional area, only increases by a squared factor. That dimensional mismatch right there is exactly why you can't just scale up a tiny mouse to the size of a skyscraper. It's why massive elephants must have proportionally massive, thick tree trunk legs just to support their own weight without their bones snapping under the pressure. Biology itself is entirely constrained by dimensional analysis.
So the crucial point is that pure dimensionless numbers actually dictate the fabric of reality. Consider the number 1/137. This is known as the fine structure constant. It characterizes the precise strength of the electromagnetic interaction in quantum mechanics. And because it's a pure ratio, its value is entirely independent of human measurement units. It literally doesn't matter if you measure in meters or, alien light cycles. Any advanced hypothetical civilization anywhere in the cosmos would measure this exact same pure number. And that scale, from the biology of elephants down to the quantum mechanics of atoms, well, it's really just the beginning. Let's zoom out and look at the biggest picture possible.
Section 3. Scaling the Universe. Cosmic Applications. The historical evolution of this concept is a thrilling ride of rapid, massive scientific discovery. Check this out. In 1822, Joseph Fourier formally defined mathematical dimensions in his theory of heat. Fast forward a bit to 1872, and Lord Rayleigh used these very concepts to explain exactly why the sky is blue. By 1914, Buckingham proved his famous pi theorem. Then, in 1941, Andrei Kolmogorov used pure dimensional logic to derive the scaling laws of chaotic turbulence. And of course, in 1950, G.I. Taylor used it to reveal that classified atomic bomb yield. It proves that dimensional analysis is definitely not just some dusty old textbook rule. It is a highly active engine of continuous discovery. And this brilliantly illustrates how dimensional analysis successfully derives laws for absolutely everything. I mean, everything! By simply analyzing the dimensions, physicists have successfully derived Kepler's third law of planetary orbits. They found the precise equations for the speed of sound. They've even calculated the Schwarzschild radius, which is the exact event horizon point of no return for a black hole, and mapped Hubble's law for our rapidly expanding universe. All of this is done just by demanding that the mathematical equations balance their base dimensions. How cool is that? Now, when you push this logic to the absolute limit, you get what we're talking about here: Planck units. This is exactly what happens when we drop human conventions entirely. By combining the fundamental constants of nature, the speed of light, the gravitational constant, and Planck's constant, we can construct completely unique units of length, time, mass, and temperature. The Planck length and Planck time represent the mind-bending extreme scales where quantum gravity totally takes over. It's the literal natural language of the universe, completely unpolluted by human choices. But hey, the story doesn't end with theoretical astrophysics. The torch of dimensional analysis is actually being passed to advanced machines right now in cutting-edge research from 2022 up through 2025.
Section 4. AI and Dimensions. The Final Frontier.
Let's move to and see how this builds into a revolutionary data-driven approach called dimensionless learning. See, complex systems like modern climate models or sprawling biological networks are incredibly difficult to map. But AI algorithms, like the recently developed BuckyNet, are now autonomously searching through scarce measurement data to find hidden scaling laws. The AI is literally doing the dimensional analysis for us. It's discovering dominant dimensionless numbers to explain complex systems completely automatically. It's a real game changer. But to bridge human intuition and machine learning, researchers have to rely on a principle called units equivariance. What that really means is that even the most powerful neural networks must be strictly constrained by the rule of apples and oranges. When we train AI on physical data, we have to absolutely ensure it respects dimensional constraints. Because otherwise, the AI might just output complete physical nonsense. The universe's rules still apply, even to our most advanced computers.
Which brings us to a final, truly provocative thought. Physicists face something called the hierarchy problem. It's the deep mystery of why fundamental dimensionless ratios, like the massive difference in strength between gravity and electromagnetism, are the exact, specific numbers that they are. If all physical laws must boil down to dimensionally consistent formulas, it leaves us staring at the screen wondering, is the very fabric of reality, the entire cosmos, and our existence within it, just an elegant coincidence of pure, dimensionless numbers? It is a profound mystery to ponder the next time you try to measure something. Thank you so much for joining me for this explainer. I really hope it completely changed the way you view the dimensions of our universe.